Hello everyone, this is Sagar. I am here to discuss with you about sentimental analysis using NLP with logistic regression and naive-based model. Let's deep dive into it. First, imports. We are importing string, NLTK, NumPy, regular expressions, and from nltk.corpus we are importing Twitter samples. This is the data on which we perform the sentimental analysis and also stop words. These are common words in English language such as I, am, myself, you, yourself, etc. These words will be filtered from the tweets as the words will not show any impact on the sentence. And next, for streaming we'll use Porter Streamer, and for tokenizing we will use Tweet Tokenizer. We can download it using nltk.download Twitter samples and nltk.download stopwords. After downloading, we should load the dataset. Twitter data. The Twitter sample contains already separated positive and negative tweets. Each contains of 5000 samples, and we divide it into 80-20%, which means 80% of positive tweets to training and 20% of positive tweets to testing. Same for the negative tweets as well. After dividing it, we will go to the processing of the tweet, which is pre-processing. First we tokenize the tweet. Which is splitting the sentence into words. In this we have three attributes: preserve case, strip handlings, and reduce length. Preserve case equals false. In this it is used to convert to lower cases. It will not hold word as it is. And strip handles, it removes irrelevant data such as @ of usernames, etc. Reduce length, we humans drag things too much when we either super excited or too dull. In fact, we even write like this, like so good with so many words and so bad, too bad with so many words. This one will be used to reduce so many words to two words or single word. And after that we will use URL pattern for removing these URLs in the tweet. Since we download the stop word, we will be using these stop words to pre-process. In the tweet, if a word is either a stop word or in a string punctuation, we will remove it, since it has no use of keeping the words. And after that, after cleaning these stop words and string punctuations, we will use Porter Streamer class and remove and change the words to steamed words. You can use Porter Streamer or you can use lemmatization as well. In this I have used Porter Streamer. And the next function is the build frequency. In this we calculate occurrences of word in all positive and negative tweets. After building this, we have run through training of X and training of Y to make a frequency dictionary. And the next function is extract features. In the extract features function, we will use frequency dictionary to make features for every word with 3-dimensional. First dimension is bias, second dimension is the occurrence of words in positive tweets, and third dimension is the occurrence of word in the negative tweet. And after that we will move to gradient descent. Gradient descent function will be updating theta and loss values. In the loss value, we added here a 1g minus 15 in the log function to skip the undefined values. If h value is 0 or 1, we may occur with log of 0, which is undefined. To skip that, we have used this 1g minus 15. In this function, we should always be cautious about the alpha, which is a step size. This one is used to determine the movement of the theta. With the obtained theta value, we will predict whether the tweet is positive or negative. In this x is with the number of rows as a length of training x, and with the 3 columns bias positive values of order vote and negative values of the vote in this dictionary. And by extracting the futures and putting into the gradient descent, we will get the loss value as well as the theta. This loss value and the theta will be kept into the extraction of futures again to get the x value, by which we can test the data and predict the values. Since this one is logistic regression, the prediction of values will always be between 0 and 1. So if the value is above 0.5, we can say that it is a positive tweet, and if the value is below 0.5, and we can say it is as negative tweet. You can see in this. By obtaining the prediction of each value, we will make an array, and finally we will compare both the test value of that and the predicted value of the test x. By this function you can calculate the prediction value and compare with the test y, and you finally get the accuracy of this. Okay. After that, we are also trying with the naive-Bayes model. Why are we using naive-Bayes model? Sometimes the data cannot be of perfectly divided, such as positive tweets can be of 5000 same and negative tweets can be of less values. While in that time the data will, as the data is different, it can show difference in performance. So it will show more towards logistic regression, more positivity towards the logistic regression than negativity. In naive Bayes, it shows as unbiased. We can get this using log prior values. Using log likelihood, we can find probability of vote in positive tweets compared to negative tweets, and log prior is the log of probability of positive tweets to the negative tweets. This is very useful when data set is imbalanced. Finally, by summing up log prior and log likelihood, we get a value between minus infinity to plus infinity. If I get a value above 0, it means that it is indicating it has a positive expression. If the value is below 0, it shows that it has negative expression. By comparing y prediction and test y, we can get the accuracy of this. So after this, we will run and check the accuracies of both the models. You can see that accuracy of logistic regression is 99.45% and naive Bayes accuracy is 99.55%. Let us see with the change of data, where positive values are same and negative values are changed. We are changing this test values to 4400, which is only 600 models, and training to 2400, which is only 2400, total of 3000. We are keeping the same ratio of 80% to 20%. You can see there is a drastic decrease in the logistic regression, whereas naive Bayes model has only decreased a little. So it is always better to use a naive Bayes model when the data is mid and no controversies in the data. Thank you.